What the hell is the cloud? I know you've been asking yourself for a while this, and you didn't dare to ask others because everybody seems to know what the cloud is. And you know what? You're in good company. A lot of people don't know because, by the way, I looked on YouTube, I looked everywhere, and I tried to find some better videos without me having to explain it. But there aren't. So here it is. This video is going to tell you everything you want to know about the cloud, but you never dare to ask, and we are going to start now. Hello again, and thank you for joining me. I'm Paolo. I'm the old Italian guy with a funny accent talking about technology, and isn't that thing impressive? What's the point of that? Absolutely nothing. It's just a cool background that I wanted to put together for a while. Anyway, so I thought it was good to put together now to show it for this episode of the People's Tech channel, where we are talking about the cloud, the famous cloud. What the heck is that? Why is everybody talking about it? And why it seems to be such a great thing. So this actually came from a friend of mine, and she said, you know what, you should talk about the cloud. And I said, oh, okay, that's a good point. I looked on the net thinking there must be something else already there that is just talking about it. And you know what, there is, as usual, stuff that is out there, but it is for nerds, for people who are already in the technical field. And I wanted to make sure that everybody knows about this. So to understand better what the cloud is, we actually have to go to the origin of the computer. That's a funny thing. And because otherwise it doesn't make any sense. And I promise this will be short and sweet. So first of all, what the heck is a computer? I know that you can recognize one, but really, what is a computer? What is the definition? How we define this thing? So a computer, unlike a screwdriver or a chainsaw, very specialized tools, a computer is a very general tool. It's a tool that is designed to be programmable. A computer is a computation machine. What the heck is that? So you know what a computer is from the outside, but inside there are many different components. The main part of it, what makes a computer, is the processor, also named a central processing unit or CPU. Now the CPU is not the box, it's not the base of your laptop, it's not the screen, the monitor, none of that. The CPU, the central processing unit, the processor, the microprocessor, the chip, call it what you want. There are many different nicknames for it. Is a circuit. It's a humongous circuit. It's a die, it's a square of silicon that contains billions with a B of transistors. Those transistors are printed in a space of few nanometers, very, very, very small. You need the microscope to actually see them. And all these transistors strung together create some incredibly complex circuits. The purpose of those circuits is to define the operations that the computer can do. Those operations are simple, very, very simple. They are things like addition, subtraction, multiplication, division, plus other things like moving data from the memory to the processor, moving data from the processor to memory. Now, memory is not your hard disk, that's storage. The memory is the RAM, the random access memory. That's what RAM stands for. Now, the RAM is another form of electronics. It's some sort of a processor that, instead of being generic, is very, very specialized. It's a storage of data. So think about this. Let's say that you want to add two numbers together, okay? You're asking your computer to do it. Well, we're gonna have those numbers somewhere in memory. The program knows where that is. Might be a spreadsheet, it could be Excel, for example. So we have number A, number B, and we want to add them together and obtain a result. So a computer will go about that in this very simplified manner. The computer will execute an instruction that says, go to this address in memory, fetch the data is there, and bring it inside the CPU. Where does that go? The CPU has specific little memory locations which are internal to the CPU, to the processor, and they're called registers, okay? So we are moving a number, a value, from memory into the register. Why are we doing that? Because until the data is inside the registers of the CPU, cannot be manipulated, okay? So we are copying from memory to the register A. Then we are copying another value from memory to register B, and then we execute the operation add. And that will copy the result into register C, and then we execute another instruction that takes the information from register C and copies it to memory, where it will be handled in some other way. That is what a CPU does, okay? Basic little instructions. So think of those as the Lego bricks, and then you're building this monumental castle. But at the center, there are very, very small bricks. And that's what the processor does. It has very small instructions, but they can be strung together into what we call a program or app. Nowadays, we all use the word app. App is short for application or program, same exact thing. Okay, so that is what a processor is. It's a CPU that has a certain amount of instructions. So what does that have to do with the cloud, you might say? We are getting to it. Now, think about this. A processor has a set of instructions. So those instructions were, in the past, executed one after the other in sequence. One after the other. One instruction, then the other, then the other, then the other, then the other. You couldn't get to instruction 4 until instruction 3 was executed, okay? This is a sequence. Now, even back then, processors could create the illusion of multitasking. Multitasking is when we see multiple programs running at the same time. For example, you might have a YouTube video playing on your browser while your word processor is printing your next American novel on the printer. They're running at the same time, or so it seems. What's happening there when you have a CPU that is strictly sequential is that the CPU will give a little bit of time to the YouTube video, and then it will switch to the printing document, and then we'll come back to YouTube, and then we'll go back to the other program, and we'll continue to do this. And of course, actually, we are not talking about two programs, but we are talking about possibly hundreds or thousands of instructions and little subroutines that are executed at the same time. It's a sort of a juggling act, okay? Well, that works with one single CPU, but think about this. What if we actually have two CPUs running in parallel? Now, one program, one CPU can execute the playback of your YouTube video, and the other one can do the printing. Fine. So those are two parallel CPUs, but you're thinking, well, how do we put two processors in the same machine? Okay, that's actually possible, but we came up with a better solution. Instead of adding multiple CPUs, Intel and other manufacturers came up with a genius idea of saying, look, we're going to have the same die, the same square piece of, of silicon, but with all the pins that go in the circuitry, in the motherboard, instead of having one set of instructions, we're going to have two copies of the same set. So all those instructions, addition, subtraction, moving to and from memory, all that great stuff has been duplicated side by side, or one on top of the other, doesn't matter how physically it's done. But think about that. Side by side, the same set of circuits, the same billions of transistors have been duplicated on the same processor, so that now that processor can execute multiple operations in parallel, not in sequence. That creates a speed up that is dramatic. But how do we call that? It's called a multi-core architecture. So with two copies of the same instruction set, you have a dual-core processor. That's what it means. Now, of course, if you quadruple there, then you quadruple the instruction set. You have a quad-core processor, an 8-core processor. Today, we have processors that go up to 64 cores. And yes, they're very expensive, and they're beautiful, and they are incredibly powerful. Now we're getting to the cloud. What do we do with, I don't know, a 32-core processor? I mean, there are some users who will take advantage of that. But for the most, a lot of people don't need it. You can be probably okay with a 4 or 8 core processor nowadays. It will do a lot of good stuff for you. Okay, but if I put a computer with that power on the net, somewhere where it is accessible by multiple people, then I can create applications like Google Docs, Google Sheets, and so on. I can create applications that people can use inside the browser. And so now you have people able to write on the same document at the same time, because we have these incredibly powerful machines, and we don't just have one, but data centers like the ones operated by Google and Facebook and Amazon. They have a mind-boggling amount of computers in each computer with multiple cores, a lot of memory, lots of storage. And that's why we have applications like Dropbox, for example. A Dropbox is your folder on the net, on internet. That is a cloud application. There is a program that is running somewhere else, and a portion of that program also runs on your machine. And those two programs talk to each other. So the Dropbox program on your machine takes the data from the folder that has been designated to be the Dropbox folder, and then pushes that over the net. Now, when you're connecting to your same Dropbox account, not from your computer, but from your phone, then that data is synchronized. The power of having something like that is extremely useful. In fact, to me, Dropbox is the only thing that makes the iPhone usable. Without a file system, the darn thing is pointless. And so Dropbox is one example. Google Docs is another example. Google Sheets is another example. There are many other examples of this. When there is a service called AWS, the Amazon Web Services, which provides you with computers that you can rent over the net. One of the biggest examples of that is Netflix. How does Netflix stream all those movies to your smart TV right there, almost instantaneously? It's because there are all these incredibly powerful computers that are connected over the net. And so when you are requesting a movie from Netflix, Netflix, first of all, examines where you're calling from. It's not a call, it's not a telephone call, but it is a call that you're making from your smart TV, from your Roku, from your Apple TV. You're making that call to Netflix services. So they will find out where you're coming from, because in that way they can dispatch that request to the nearmost server that Netflix operates. And Netflix uses the power of the cloud because Amazon has this service called Amazon Web Services, where Netflix can rent a CPU on demand, a processor, a computer actually, on demand, and use that machine, which is called an instance of a machine. So think of that as a virtual computer, okay? They operate that virtual computer on demand to satisfy your request. So by using all these multi-core machines, all strung together, all connected together, and then connected to us, we have that power, that flexibility of having an enormous amount of processing power on demand served to us through the internet. In a way, the internet is the cloud. Without the internet, there is no cloud, okay? The point is that with the evolution of CPUs and the fact that now they are very inexpensive, especially for companies like Facebook and Apple and Google and Netflix, etc. By making all this power connected together, then we have this flexibility, especially because today a lot of us are using all kinds of devices together. It's not uncommon to use a computer, a phone, and a tablet together. So you want to be able to share your information. And how is that done? Instead of passing the information, passing the files from one machine to the other, still can be done. We use services like Dropbox. And Dropbox is a cloud service. It's a virtual folder on the net. And so your phone can retrieve data that was written by your computer on that same folder, and that resides on the net. Dropbox has the power of doing that because they can use all these CPUs on demand provided by companies like Amazon or Microsoft or Google, that they provide all these machines that have these huge data centers. And for example, if you have a CPU with 32 cores, then you can allocate some of those cores to one company and some of those cores to another company, some other cores to another company, depending on the load. There are programs that are designed to automatically and dynamically adjust the load that comes from several requests to multiple machines. It's not a mystery, for example, that it's faster to retrieve information from Google than doing a search on your own local computer. That is because of the enormous amount of parallelism and the enormous amount of machines that are all connected together so that the load can be distributed and then returned to you very, very quickly. So I wanted to keep this very, very general, very high level. I hope this was helpful in any way. If you need more details, please leave them in the comments below in the video. Thank you very much again for tuning in. I'm Paolo with the People's Techs channel. Thank you for watching. Ciao.